Hello everyone. In this video we are going to be taking a look at the event detection and the data logging part of our project, and for the same we have made a use of the auto transformer that you can see here. This has been used to vary the voltages because previously we were using the single phase AC supply here, but now so that we can get varying voltages we will make use of the auto transformer. We can see that the supply is connected across this auto transformer. So this voltage will be changed and we will be able to see different events that occur in the power supply system, namely sag, swell and voltage interruptions, etc. So here we have the front panel of our VI as seen earlier, and through this we're just going to demonstrate the different events occurring in a power system. And we have something called as interruptions, as you can see here. Interruptions are basically when the voltage dips below 0.1 pu of the nominal value, and then also we have sag, that is when the voltage is from 0.1 to 0.9 pu, and also the next one here is a voltage swell, and this occurs if the voltage is greater than 1.1 per unit of the nominal voltage. So right now, since the voltage is at 228 volts, that's the RMS value, we have the normal bulb glowing because this is a normal working voltage. As per the IEEE standards, for interruptions it is less than 23 volts. That is, the value of the voltage, if it dips below less than 23 volts, it is called as an interruption. For sag, the value is from 23 volts to 207 volts, and for a swell it is greater than 253 volts. That is as per the IEEE standards, like I mentioned, 1.1 pu. So for 230 volts single phase AC supply, it will be something greater than 253 volts. So in case of our auto transformer here, the maximum voltage comes up only to about 240 volts, and so we will not be able to display the swell part here. We are however going to have a look at the sag and interruption and the normal voltage. So right now, as we see, the value of the voltage is at 202 volts, and this is less than 207, so this classifies as a sag. So we can see here that the sag bulb is glowing, and we have further classifications here that's called instantaneous sag, momentary sag, temporary sag and under voltage. So if the value of the voltage is below the threshold for about 3 seconds, it classifies as an instantaneous sag. Anything greater than 3 seconds and up to 30 seconds becomes a momentary sag. 30 seconds to 1 minute is a temporary sag, and anything greater than 1 minute is classified as an under voltage. So we're just going to have a look at the screen now and wait for it to be about a minute's time, after which the under voltage, here we have it. The under voltage bulb is now glowing because the value of the voltage has been 200, now it's come up to 177 here. So even for 177, the value of the voltage has been there less than 207 volts for about a minute's time, so it's called as an under voltage. Now we're going to have a look at the interruption. So let's just wait for the voltage to vary to a smaller value. So now the value of the voltage has come up to 24 volts, and this is less than the specified threshold for interruption, and the voltage now is 20 volts. As we can see here, the voltage RMS value is 20.95, and since this value is less than 23 volts, we can see that the event that has occurred here is an interruption. And in interruption, again, as I mentioned before, there are further classifications as instantaneous, momentary and sustained. Now the momentary bulb is glowing right now, which implies that this interruption has been there for more than 3 seconds, and now when it becomes anything more than 1 minute, this will become a sustained interruption. This is a data logging part of the virtual power analyzer, and this is the VI that will be able to tell us which event had occurred at what time, and we'll also be able to log this data into an Excel sheet using the TDMS facility in LabVIEW. And so we'll be having a very accurate and a precise detail as to which event had occurred at what time. And this is the front panel for that. As we can see, it displays the current status of the system. If a voltage interruption has occurred, the present time, the start time of the voltage interruption, and the elapsed time, the duration for which this event has occurred. We also have below the voltage sag and the voltage swell. That's, again, they have their start time and the elapsed time. So using the same auto transformer, we are just going to vary the voltages. And for display of the swell here, we'll be able to demonstrate the swell factor as well. So for that, we have made a few changes in the ranges here. For interruptions, the value remains the same, that's 0 to 23 volts. For voltage sag, however, we have made the range to be 23 volts to 180 volts. And between 180 volts and 207 volts is something called as normal voltage, that's our normal working voltage. And anything greater than 207 volts has been declared as a swell. This just for explanation purposes so that we can display the occurrence of all of these events and the logging of the same. So right now I'm going to ask Devdutt to just change the value of the voltage. And we're going to start with the swell. So the value of the voltage has to be greater than 207 volts. So as we can see, the voltage swell has occurred and it is showing the start time as 11:54 a.m. and the present time is 11:54 and 53 seconds. So the elapsed time for the swell is about 16 seconds. And the same can be logged in an Excel sheet, which we're going to be able to see. And the current system status is temporary voltage swell. Once this crosses about a minute's time, it will become a sustained voltage swell. So the current system status is temporary voltage swell. After a minute, like we can see here, the value has now changed to a sustained voltage swell because it has elapsed for more than a minute. We can see that here. The elapsed time has now become 70 seconds now. So we are able to see that after a minute's time, the temporary voltage swell became a sustained voltage swell. Now we are going to take a look at a normal voltage. That's our working voltage. The range for this is 180 volts to 207 volts. So as we can see, the current system status is as normal voltage. And now coming on to the sag part. So now the voltage has been reduced to something that's between 23 volts and 180 volts. So that classifies as a sag. So here we can see that the start time of the sag is 11:56 a.m. and the elapsed time is 14 seconds right now. So we'll be able to log this data onto a Microsoft Excel sheet using the TDMS facility, and using that we can make a profile using the diagram, etc., and we'll have a behavioral pattern with us through which we can make further analysis and come up with preventive measures so that these events do not occur in the power system. So the current system status is a temporary voltage sag. And we see that the elapsed time is 56 seconds. So after this touches 60, we're going to have a sustained voltage sag. Like we can see, the time here is 64 seconds, that's greater than a minute. So the current system status is a sustained voltage sag. Now we're going to go ahead and have a look at the interruption. So just as soon as it occurs, we have a momentary voltage interruption and a temporary voltage interruption depending upon the time for which it has occurred. And we can see that the start time here is 11:57 a.m. and the interruption time now is 13 seconds. So where does this thing come in handy? Just in case we go in for a break or something like that, we are not near the monitoring tool, how will we know as to what event had occurred in that small lapse of time? So that is where this one will come in really handy, and we'll be able to see firsthand what event had occurred at what time and how we can curb it and have a behavioral pattern with us. So now we'll just go ahead and have a look at the event logging part of it. That is, I have an Excel sheet with me that will be able to tell us exactly So this Excel sheet that I'm opening now is for a voltage interruption, and we can see that this first column is the time column, wherein we'll be able to see the time, the present time since the interruption has occurred. The time here is the time in seconds since the program was started. This column, the third column here, the C column, is actually the column that actually tells us the duration of the event. And the fourth column is the value of the voltage, the RMS voltage at that particular instant of time. So on the 20th of July 2013 at 11:54, the voltage was 229 volts. And since this is not an interruption and this is actually a voltage swell, the value of the duration column is 0, as we can see here. As we go down, when we had displayed the interruption event, we are able to see the details here. At 11:58 a.m. there was an interruption that had lasted for 8 seconds. The duration of the interruption was 8 seconds, and the value of the voltage then was 21.5 volts. So this makes it clear that the value of the voltage was this at this particular instant, and so the event has occurred for this much duration of time. This will help us figuring out the peak hours in which the energy consumption is most, and how we can curb this, or how we can add filters, etc. to our power system, and we can curb this event from occurring. So let's go on to the sag part. I have it in another Excel sheet here. Again, since we had started with a swell, initially the value is 0 in the duration column because the event has not occurred. Now, when the value of the voltage was approximately 171 volts, that's less than 207, this classifies as a swell, a sag, I'm really sorry. And so we have the sag event occurring here for 1 second, 2 seconds, 3 seconds, etc. At every instant, there is a value of the voltage and the duration for which the event has occurred. And again, at this instant, the value had become less than 23 volts. So that's why the value of the voltage is now 21 volts. And since that's an interruption, again, the sag volume has become 0. The duration of the sag has become 0. So, similarly, we have for the swell part of it as well. As we can see, the value of the voltage is 229 volts, which is much more greater than 207. So this event classifies as a voltage swell. And so at the start of the program, that was at 11:54 a.m., we had created a voltage swell just for demonstration, and we have that the voltage has swelled for about 1 second, 2 seconds, 3 seconds, etc. And as we go further below, now the voltage has come up to below 207 volts. So we are able to see that a voltage sag has occurred. And as we go further below, if the value of the voltage changes further, here we see that the value of the voltage has come to 21 volts. And since that's an interruption, the column for the swell duration has become 0, and it displays a 0 value. So this is our project that we have made. It's called a virtual power analyzer. And we've tested it against the fluke meter as we've seen earlier for comparison, and we also have the event detection and the event logging functionality, which can be helpful in determining which events have occurred and how we can cope with them and create a more better power system, and that is the need of the hour. Thank you.